Hi, I'm Jake Garn, robotics and automation student.
And you're here to show us your conveyor program?
Yep, this is our ladder logic for the conveyor system. See, we have our start button, our emergency stop, goes down to our start process contact. That'll seal itself in so that we don't have to have the start button pushed in all the time. When we execute the emergency stop, that will stop the entire process, conveyors, and all the sorting processes through the camera and all the sensors.
And that gets wired into these buttons right here.
Yep. Right. Start, stop, green light, emergency stop.
Okay, terrific.
As we move down to the next rung here, we have the contact again, the start process. That's going to come through. That's our contact for the conveyor belts to run and our green light to turn on. And then this is going to be, that's going to be our stop button process rung. Once the start button's hit, it will continue the run through. Or if you hit the stop button or the emergency stop, it will stop the process.
Right.
But the stop button will only stop the conveyor belts. All the sensors and everything are still active.
And these are your the sensors for the glass sorting. You have glass, you have dispersal delay.
Those are our arms there. That's the that's for our two push stop pins down there at the end.
Okay.
Assuming that anything is closed, arm 4, that's one down here, and arm 2, that's the one here in front of you. Or the glass material is active, because there's nothing to stop it. That's just when that process is active. It will go through a parallel circuit to distribute power one way or another.
Right.
And moving down, we have a delay timer, so that when the bottles actually come through, they get laid down so they're in front of a sensor for a period of time, and nothing can run through at the same time. So what happens if we don't have that delay in there, it'll send items down, but it won't distribute them down their correct path.
Mm-hmm.
So we had to put a timer in there to wait 2 seconds if a bottle gets done before it sends down anything else.
So this is actually a pretty long program.
This is a decently long program. I think it's 31 rungs or 32 rungs. This is going to be our glass process here. Assuming we trigger our what we're calling a break line sensor. It's just a beam of light that shoots across to a reflector plate. If it's broken, it decides that an object is present. That's our object sensor. Bottle sensor, that's the same kind of sensor, just tall. And then we have that go down to a contact and seal itself in until the glass is hit on its own safe sensor down here, another what we call a break line sensor. And that will stop the process. And that'll go back up to the top where the dispersal pins are and open them back up to send the next object through. In the case of tin, we have to have the path for the aluminum cans that says arm 2 open has to be active and open. And we also have to trigger our tin selection sensor, which goes down to a timer. And if that happens, it'll hit the aluminum sensor as well. And if both those sensors are active, it determines that it's a tin can. It'll send it through until it hits down, which will be towards the bottom. It'll hit a sensor that will stop the tin sorting process and send the next item through. The long rung here with all the contacts on it, that's our aluminum sorting rung. Mm-hmm. It's got the object sensor, the aluminum sensor, the tin sensor, our tin timer, the tin sensor itself, the glass safe zone, and the tin safe zone. So the way we have it set up, we have to have the object sensor active, the aluminum sensor active, the tin process not active, the tin timer not active, the tin sensor not active, the glass safe zone not active, and the tin process again I got placed in there twice in order to go through to the contact and start the aluminum sorting process.
Right.
Now down here where I mentioned earlier, these are our safe zones. When the glass safe zone hits, everything else still has to be inactive. There's no two processes that can occur at the same time. So we have multiple contacts in there for a condition set to stop any two items from going down at the same time, which we didn't quite get worked out all the way to a science, but
right.
it works for the most part. We have our glass, we have our aluminum set, and that'll go to the aluminum safe zone. And then we have our tin sort process, comes down. These are the two triggers for each one, aluminum and tin, that closes the gates. And we have our tin safe zone. Once we hit this proximity sensor here, that will actually trigger this contact, which if, John, do you have something metal so they can watch that light up?
Not really.
If John waves the watch in front of that sensor, it's going to light up that contact and close that gate. Well, it'll open up the gate rather, but you can see as the contacts light up.
Says that sensor put out some kind of a electromagnetic field in the
Yeah,
something about the flux lines are red. Or
it has to
something
do
like
with the
that.
field around it, and if
Yeah.
a metal object, particularly
Yeah,
for this sensor,
it'll
comes
concentrate
through.
the flux line, so it can detect metal objects like that. I see.
And we have this is for the camera. We have two outputs on the camera. We isolate one color out of the three any given time by color of choice that we have for a job. The bottle fail is when it does not meet the requirements for the color. It'll send it out and it'll spin our stepper motor and our bin to the selected bin placement until we have another sensor that senses incoming light or no light,
Right.
and it will stop the bin. I believe we have it set up to have incoming light selected. And then same down here for the camera input, that's if a bottle passes, it'll select the other side of the bin in order to drop in the selected color we wanted to isolate. Down below, this is the bottle fail. This is going to be the actual output that's down at the end, comes back down here, and it will start the motor to spin and seal it in for that particular job that we selected until the motor stop for that job stops the motor from spinning. Same thing for the past bottles. It'll go through, it'll spin the motor until we get to that sensor. And those sensors are staggered across the barrel to stop it for its selected position. This is going to be our pulse for the stepper motor. It requires a pulse in order to spin it. It
Right.
spins on 1/5 ratio. So 1/5 of a turn every pulse. We have it pulsing at 1,000th of a second.
Okay.
And then these are going to be our stop switches that we have on the barrel, stop 1, 2, and 3. We
Right.
originally had 3 sensors. It got cut down to 2. I just never replaced this third rung. And we have our camera trigger. That's another brake line sensor. If an object breaks that line, it tells the camera to take a picture.
Right.
And then this will be the process through the camera where the bottle passes or the bottle will fail. And that's going to go to our contacts actually up top.
Here's another project.
And you're cool.
And this is really just all the e-stops and counters.
Yeah.
The glass safe zone triggers it to count the glass. We have our tin, our aluminum, and then based upon pass or fail of the bottles, it also counts those. And then to reset them, we press the emergency stop and the stop button all at the same time, and it will reset each of our counters. John, if you want to do it, it will actually show ranking on there. All of our counters reset down to 0.
Right. Awesome.
And that is the gist of our program.
Okay. All right. Good job, guys.
All right. Thank you.